Alright, so this is definition of continuity at a point. So there are three basic rules for determining continuity at a point. Number one is if the limit of f of x as x approaches c does not exist, a point c, then the graph is not continuous at that point. For example, in this graph we can see that at point c, the limit from the left and the limit from the right approach different points, so the limit does not exist. And number two, the point would not be continuous if f of point c is not defined. So on this graph we can see that at point c, while there is a limit, the point itself is a hole, so it's undefined. So it cannot be continuous at this point. Or, number three, if the limit of f of x as x approaches point c does not equal f of c. So in this graph we can see that there is a limit here as x approaches c, and there is a point at c, but the point, the f of c, does not equal the limit. So we have three examples here to test these out. So number one, we have a piecewise function, f of x equals x plus 2 if x is greater than 4, and 2x plus 4 if x is less than or equal to 4. So the question is f continuous at x equals 4? So we're going to look at our three rules, our three instances in which the function would be discontinuous. So we're going to look at number one first. If the limit as x approaches c of f of x does not exist, c in this case being 4. So we would write out the limit as x approaches 4. We're going to first try to, since this is a piecewise function, we're going to first have to solve for the limit as x approaches 4 on the left. So here, the bottom part of the function would be 4 from the left because its x is less than or equal to 4, so we know this is when it's approaching on the left. So the limit as x approaches 4 from the left of 2x plus 4. We can plug in our 4 for x, and we get 2 times 4 plus 4, which is equal to 12. So the limit as x approaches 4 from the left is equal to 12. Now we can solve for the limit as x approaches 4 from the right. That would be the top part of the function, because f is greater than 4, so we know that part of the function is approaching from the right. So the limit as x approaches 4 from the right of x plus 2. We can plug in 4 for x, and we get 4 plus 2, which equals 6. So the limit as x approaches 4 from the right is 6. However, the limit from the left, 12, does not equal the limit to the right, 6. For the limit to exist, the left and the right limits have to be equal. And so because 12 does not equal 6, the limit does not exist. And so thereby that means that the function is not continuous at x equals 4. So we'd write that out as f is not continuous at x equals 4 because the limit as x approaches 4 of f of x, dne, does not exist. And so, we can move on to number 2. We have another function, f of x equals 3x plus 1 times x minus 2 over x minus 2. So the question is f continuous at x equals 2? So we go back to our first step. We're going to find the limit. The limit as x approaches 2 of 3x plus 1 times x minus 2 over x minus 2. So we can simplify that because x minus 2 cancels out on the top and the bottom. So we're down to limit as x approaches 2 of 3x plus 1. And so we can now plug in 2 for x. 3 times 2 plus 1. And so from that we get 7. So we know that the limit as x approaches 2 equals 7. So the limit does exist. So far we're good as far as continuity goes. So we're going to move on to our number 2. Is f of c defined? C being 2 here. And so when we look back up here at the function, we cancel out x minus 2 from the top and the bottom to simplify the equation. And if we cancel out the value in the numerator and the denominator, it creates a hole in the function. And so we can find what that hole is by putting x minus 2 equals 0, add 2 on both sides, at x equals 2, there's a hole in the function, which means that a point doesn't exist at x equals 2. So that means that f of 2 does not exist. So it is not continuous at x equals 2. So we can write that f is not continuous because even though the limit exists, number 2 of the rules is not satisfied, and so it's not continuous because all three of these cannot be true for it to be continuous. F is not continuous at x equals 2 because f of 2 d and e does not exist. So we can move on to number 3. We have another piecewise function, f of x equals 4x times x minus 3 over x minus 3 if x is not equal 3, and we have 2 if x equals 3. The question is f continuous at x equals 3? And so we go back to our first step, solving for the limit. Limit as x approaches 3, we can use this top function because even if 3 doesn't exist in this function, we can still solve for the limit. So we have the limit as x approaches 3 of 4x times x minus 3 over x minus 3. We can cancel out x minus 3 from the top and the bottom, and we get 4x. We're down to limit as x approaches 3 of 4x, and we can plug in 3 for x now. 4 times 3 equals 12. So the limit as x approaches 3 is 12. So the limit does exist. So we're good on that. We're going to move on to number 2. Is the point defined? What is f of 3? Well, we can see here that if x equals 3, then f of 3 is 2. And so f of 3 equals 2. Now, that means that the function is, or the point is defined in the function. So we move on to number 3. Does the limit of f of x as x approaches point C equal f of c? So we have the limit, we have 12. Now does 12 equal the point? 2. 12 does not equal 2. And so the limit is not equal to the defined point, and so the function is not continuous. So we would write f is not continuous at x equals 3 because the limit as x approaches 3 equals 12, which does not equal f of 3, which is 2.